Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the modulus of rigidity and bulk modulus, the two elastic moduli that describe how materials resist shape change and volume change. Let's begin. The modulus of rigidity, also called the shear modulus, is defined as shearing stress divided by shearing strain, and it specifically measures the solid material's resistance to a shape-changing, non-volume changing deformation. Imagine pushing the top face of a cube sideways while its bottom face stays fixed. That's exactly the kind of deformation shear modulus quantifies. Shearing strain itself is measured as the angle of deformation, in radians, that a genuinely originally vertical face tilts through, under the applied shearing stress, and since this angle is genuinely small for real elastic deformations, shearing strain is dimensionless, just like the other strain types. A critically important point: fluids, liquids and gases cannot support any shearing stress at all, since they simply flow freely, in response to any applied shear rather than developing an internal restoring force. This is exactly why fluids have no defined shear modulus whatsoever, and it's precisely the defining mechanical property that actually distinguishes a genuine solid from a fluid. Bulk modulus is defined as volume stress divided by volume strain, with a conventional negative sign included, since increasing pressure always genuinely decreases volume, and it specifically measures a material's resistance to uniform compression from every direction simultaneously. Imagine submerging an object deep underwater, where pressure pushes inward equally from all sides. Unlike shear modulus, bulk modulus genuinely applies to solids, liquids, and gases alike, since uniform compression, unlike shear, is something every state or matter can meaningfully resist to some real degree. Compressibility is defined as the simple reciprocal of bulk modulus, and it's a particularly useful relevant quantity specifically for describing fluids. Gases are dramatically more compressible, and therefore have a much lower bulk modulus than liquids, which are themselves considerably more compressible than solids. This specific ordering directly reflects how tightly packed and strongly interacting each state's own constituent molecules genuinely are. The single most frequently tested distinction in this entire topic is genuinely simple: shear modulus applies only to solids, since it requires resisting shape change without volume change, something only a genuine solid's rigid internal structure can actually achieve, while bulk modulus applies to solids, liquids, and gases alike, since uniform compression resistance is a genuinely universal property of matter. A common G-trap directly tests this exact distinction, asking specifically about the shear modulus of a liquid, and the genuinely correct answer is that it simply doesn't exist. Liquids offer zero resistance to shape-changing shear stress. Another frequently tested numerical connects all three elastic moduli, Young's modulus, bulk modulus, and shear modulus, together through a single relationship involving Poisson's ratio. Though for most standard JEE problems, correctly identifying which specific modulus actually applies to the given physical scenario is considerably more important than memorizing that more complex combined relationship. Let's recap. Modulus of rigidity, shearing stress over shearing strain, measures resistance to shape change and applies only to solids, since fluids cannot support shear stress at all. Bulk modulus, volume stress over volume strain, measures resistance to uniform compression and applies universally to solids, liquids, and gases, with compressibility as its simple reciprocal. In the key G-trap to remember always, liquids and gases genuinely have no shear modulus, but they do have a perfectly well-defined bulk modulus. That's the modulus of rigidity and bulk modulus. Keep the solids only for shear versus universal bulk modulus distinction sharp. It's the single most reliable trap in this topic. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.